Meet Richard James, born on January 1st, 1914. He was a naval engineer in the early 1940s. During this time, he was working to develop a way to create an anti-vibration device for the instruments on the naval ship. When it failed to work for the Navy, he and his wife, Betty, decided to sell the failure as a toy and call it a Slinky. So later that year, Richard and his wife decided to demonstrate their new toy at Gimbel's department store, located in Philadelphia. They feared that no one would buy it because it was such a simple design. They were so worried that they gave a close friend $1 to buy one. An hour and a half after the first demonstration, they had sold a total of 400 Slinkies. Take a look at this article about Richard James himself. How did he originally get the idea for the Slinky? Not much has changed about the Slinky since its original design of a metal coil wire. Some Slinkies are now made of plastic, have cool designs on them, and have even become a popular toy in the movie Toy Story. Here are a couple of examples of how the Slinky has made our lives more entertaining. The Slinky, like all objects, tends to resist change in its motion. Because of this inertia, if it were placed at the top of the stairs, it would stay at rest without moving at all. At this point, it has potential or stored energy. But once it is started down the stairs and gravity affects it, the potential energy is converted to the energy of motion or kinetic energy, and the Slinky gracefully tumbles coil by coil down the stairs. There is one other property of a Slinky that not many people know about. Take a look at this video. In this picture, the Slinky is completely stretched out, and if let go, will end up on the ground due to gravity. But how will it hit the ground? Option A. Do you think the Slinky will release at the top, then join to the coil on the bottom and fall to the ground? Option B. Will the top of the Slinky stay still until the bottom of the Slinky hits the ground and then continue to fall? Option C. Will both ends of the Slinky fall at exactly the same time? Or option D. Will the Slinky collect in the middle first, then fall down to the ground? Which do you think it is? Take a moment to really think about it. What forces are acting on the object? Take a minute to draw a free body diagram to illustrate the forces being used. Because we are holding it in the air, gravity is definitely one of our forces. Do you agree? So gravity is pulling or stretching the spring to the ground. But what force do you think is being used in the opposite direction? I already said it. Did you hear it? Go back and see if you can spot it. Did you figure it out yet? One more hint. Think about the Slinky. What does it look like? If you said a spring, or spring force, you're right. So, do you have a better guess of what option the Slinky might look like? Let's find out. Are you seeing this? Did you choose option A for your answer? And does your free body diagram look something like this? Let's end with the classic jingle of the Slinky.
Who walks the stair without a care and makes the happiest sound? Bounce up and down just like a clown. Everyone knows it's Slinky, the best present yet to give or get, the favorite all over town. The hit of the day when you're ready to play. Everyone knows it's Slinky, it's Slinky, it's Slinky. For fun it's the best of the toys. It's Slinky, the favorite of girls and boys. It's Slinky, for fun is the best of the toys. It's Slinky, the favorite of girls and boys. Everyone wants a Slinky, you ought to get a Slinky.
And boys and girls, more fun with Slinky full toys, Slinky Caterpillar, Slinky Train, Slinky Hippopotamus. Anonymous. Everyone wants a Slinky pull toy.